Okay, so welcome to part 2 of our module review. So looking at functions, remember every input has only one output. So number 16, right now it is a function. And I know that it's a function because I can do the vertical line test. Okay, I can draw a vertical line through each one of these points. And right now the vertical lines only touch in one place. So when I'm looking at these spots, okay, right now they're only touching the vertical line one time. Now, the question says add a point to the graph to make it not a function. So we want to add a point. You only have to add one. To add it and have it not be a function means that our vertical line will touch in more than one place. So I could add a point right here. Now, vertical line touches in two places. I could add one here. Now it touches in two places. I could add a point right here. Now the vertical line touches in two places. You only had to pick one point, but then add it to make it not a function. Okay, now we're looking at situations and finding the best graph to represent it. The key to looking at these graphs is to look at the labels on the axes. To see what information that it is giving you. So Luke pulled his boat in to fill it up before a day on the lake. So when he pulled it in, it says that the boat was empty of gas. So that means that there was zero gas in the tank. He then completely filled the tank up with gas. Okay, and then he uses all the gas while he's out boating. So he's starting out at 0, okay? So when we look at our axes, we have gas in the tank on our y-axis, and then we're looking at time, okay? So we know that he is starting out at 0. There is only one graph that starts out at 0. Right here on C, the graph is starting out at 0. Over time, okay, because he started out with 0 gas, he's now at the gas station. He's filling it up. It takes time. The gas is increasing, and then he goes out on the lake and he uses all of the gas. Okay? Now, if I'm being really critical about this graph, I really think that this line should probably be more out a little bit because I don't think that he would have used the gas faster than he could fill it up. But C is the best model. Okay? Right here in number 17, it says best. And we can look at A and B to compare those. A, he's not starting at 0. He's starting with half a tank of gas. And then the gas is staying the same. And then suddenly it just magically fills all the way up. With B, he's starting with a full tank of gas. He's using it up. And then somehow, without any time passing, all the gas ends up going back in. So C is our best answer. Not A, not B, but C. Now, let's look at number 18. We have a graph that is showing Simon as he is hiking. What does the horizontal line represent? Before we look at our answer choices, let's look at what the graph is telling us. We're looking at speed in relation to time. So, when Simon starts out, he's starting out down here, not moving. He's at 0, no speed. Here, his speed is increasing. He's getting faster. Okay? Well, then right here, Simon, he reaches his top speed, and so his speed is staying the same. Here, all of a sudden, his speed, it decreases. He is slowing down for some reason. And then, again, all of a sudden, he is taking off. He must be sprinting because his speed is increasing again. So, now let's look at the choices. Simon has stopped hiking. No, nowhere does he stop hiking. So, can't be A. Simon is walking at a faster pace. Okay, we're looking at the flat piece of the graph. So he's not speeding up there. Okay, he's not slowing down there, but Simon his speed is staying the same. He is at a constant rate. So D is the best answer. Looking at number 19, we have Jenny driving to work, and she has a graph that is showing the distance that she is traveling from home over time. And so we want to know what could account for the horizontal section, okay, this flat section of the graph. So let's think about what's happening throughout this graph. So as Jenny is leaving, okay, she starts going, she's going farther and farther and farther from home, okay. So she is farther from home the more she goes uphill. Well, all of a sudden, distance stops changing. Her distance is staying the same. She is still the same distance from home for this whole duration of time. Okay, so right here, the distance is staying the same. And then all of a sudden, things change, and she starts leaving, and she is going farther and farther away again. Okay, so the distance is increasing. Okay, now let's look at our choices. And we need to be careful because there could be multiple answers in this one. Okay, A, she sped up. It's not even showing speed. Can't be that. Okay, B, she stopped on the side of the road to answer her phone. Okay, this could be the time that she stopped to answer the phone. So B is a possibility. C, Jenny slowed down. Okay, again, that's speed. We're not even talking speed. D, she stopped at Pilot to get some coffee. Okay, so here she stopped again. That could account for that time. So D is a possibility. Jenny had to turn around because she left her iron at home. If that was the case, it would be going down because she would be getting closer to home. So E cannot be the answer. F, there was a train and she had to wait for it to pass. Okay. I know I have waited for some trains for a while, and so F could be a reason that she is stopped. Okay, so we're looking at these graphs, and we need to match the graph below with the situation that it describes. So we need to be thinking carefully about our graphs. Now there's 9 graphs, but there's only 4 situations. On each of the graphs, we know that the horizontal axis is time. It does not label the vertical axis, so we're going to have to think about what those would be. So if we look at number 20, okay, Tyler is riding his bike and he is at a steady rate. So that when we're talking about that rate, we're talking about speed. And then he coasts downhill, which increases his speed. So he's going to be going at a steady rate, and then all of a sudden it's going to increase. So the best answer would be C. And we're actually, with this graph, we're going to be talking speed is going to be our vertical axis. So for number 20, it is C. Looking at number 21, a tree grows steadily, okay, so it's increasing. And then when it reaches a specific height, it stops growing. So it's increasing steadily, and then it flattens out. And so when we look at that, our best choice is going to be G. And so we're talking height. And we already have it labeled. It's off the screen for me, but speed. That it increases and then it flattens out. Number 22. Okay, we have a train that is slowly increasing speed. Then it maintains a constant speed, and then it quickly speeds up. Okay, so it's increasing speed, stays at a constant speed, and then quickly speeds up. And so when we look at that, H would be the best answer for 22. That we are talking about speed, okay, versus time. Okay, 23. The speed of a bus increases, okay, at a constant rate. Don't let this constant rate fool you because that speed is increasing. It's just at a steady rate that it's increasing. Then the speed remains constant, and then it slows down and stops. And then the pattern continues. Okay? So when we look at our choices, A is going to be the best choice. The bus speed increases, it stays at a constant rate, it slows down and picks up passengers. It increases, stays at a constant rate, slows down, picks up passengers. Increased speed, constant rate, slows down, picks up passengers. And so we're looking at speed for, in regards to time. So looking at number 24, we have Joe and Henry who are eating hot dogs, and we have our progress. The winner is the first one to be able to, it's the first one to be able to eat 75 hot dogs. So we want to know who won the contest. Well, when we look at our graph, right here is 75. Okay. And so on our horizontal axis, we have the number of hot dogs. And then here on our horizontal axis, we have the time. So we want to know who, that both of them, Henry and Joe, both ended up eating 75 hot dogs, but who got there first? Well, Henry was able to eat the hot dogs, 75 hot dogs, in 80 minutes, whereas Joe would have taken about like 95 minutes. It's not labeled out here, but looking at our pattern. So Joe would have taken longer. So who won the contest? That would be Henry. Okay, so now looking at unit rates in some different situations. Now remember that when we're talking unit rate and slope, that those two things are really the same thing. So number 25, we want to compare the prices, and we want to be able to fill in the price per fluid ounce. Okay, so that means the price, how much it costs, over the number of ounces. So if we look at the mushroom soup, okay, mushroom soup is $2.28 for the price over 12. And so when we figure out that unit rate, the unit rate for the mushroom soup is going to end up being 19 cents, okay, per fluid ounce. And then when we look at the potato soup, we have $2.88 per 16 ounces. And so we do our 288 divided by 16, and that means that it is 18 cents per fluid ounce. So it didn't ask us, but if we want to know which one was the cheaper per fluid ounce, the potato soup would actually be the cheaper. Now let's look at number 26. We have Josh opening a restaurant, and so he's looking at the price for the beef stew. And so we need to look at our table. We have to find the unit rate or the slope for one serving, and then we need to find an equation to represent that. So looking at our change in y over our change in x, because x is the number of servings and then y is our cost. So we look at our change in y. Remember, for a table, to find the unit rate, we're doing change in y over change in x. So we go from $3.50 to $7. That is we have to go up $3.50. Okay, to go from $7 to $10.50, we again have to go up by $3.50. To go from $10.50 to $14, again, we're going up $3.50. $14 to $17.50, again, we're going up $3.50. Our change in x plus 2, change in x plus 2, plus 2, plus 2. Okay? And so that means that our unit rate is $3.50 over 2. And then when we simplify that we end up with $1.75 per number of servings.